Hey y'all, this is going to be a little bit of a longer video, unfortunately. This is 4.1, which is pretty substantial in length for a section, but I'll try to make it as quick and painless as possible. So we're going to be talking about linear functions. This is nothing new to us. We've already covered this before, and you've been, gone over it in an exam. So let's just kind of reiterate a little bit and expound on some as well. So we've got a linear function is a function whose graph is a line. That's it. A linear function can be written with the slope-intercept form, which is the one that's provided here. F of x is equal to mx plus b. A couple of things you need to understand. F of x is just the function of the input. It's also referenced as y. And then m is your rate of change. It's constant rate of change or your slope. And b is your initial value, okay? And it gives you that the y-intercept is at 0b. So let's see if I can do this without the light. Let's give me, oh, there we go. Horrible glare. The pressure P in pounds per square inch, PSI, on a diver in figure 4, which we don't have shown here, depends upon her depth below the water surface, D in feet. So this relationship may be modeled by the equation P of D is equal to 0.434 D plus 14.696. And they just want you to restate this function in words. So you have to understand that the pressure is based on the depth. Okay, so pounds per square inch is what this is referencing, is going to equal, for every increase in depth in feet, you're going to increase by 0.434. The starting pressure is already at 14.696. So the initial pressure is 14.696, but also check your units. In units, this is going to be pounds per square inch, PSI. Okay. Now, the next piece you're going to say is for each increase in D, which is feet, in depth, feet, will increase the total PSI by 0.434. Okay, that's it. All right, next piece, determining whether a function is increasing, decreasing, or constant. So remember, we read a graph just like we read a book. We read it from left to right. So if we're reading from left to right, notice as we're moving along this graph from left to right, we're going up, okay? So this is an increasing function. If we're going from left to right and your function is or we, then it's a decreasing function. If our function is just going horizontal, it is a constant function. So there's neither a rise nor a run, okay? And that's going to be a horizontal line in which the slope is always 0. All right, next victim. So I gave you this because you need to understand that if you're looking at a function and you're not able to see the graph itself, if you see that f of x is equal to mx plus b, there's your function. All you need to look at here is your m. If your m is positive, then that means you have an increasing function. If your rate of change or slope is negative, that just means you have a decreasing function. And if you do not have an m or an x, if you don't have any x's, then that's going to just be a constant function, and it's m equals 0. So what do these look like? I'm going to give you an example of each. Y equals 3x plus 2 would be an increasing function because the coefficient of x is positive. All right, y equals negative 2x plus 4 would be a decreasing function because the coefficient of x is negative. And finally, for a horizontal line or a constant function, it's just going to be y equals, say, 7. Okay, it's not going to have an x. You're just going to have the y equals 7 is just going to be a horizontal line. Okay. All right. One of the things you need to note with that is you're not going to have an x-intercept. It will never intersect x. Okay. One more thing is if you have a vertical line, let's just go with that as well. Vertical line. 1, it's not a function. 2, the slope is undefined. Because if you think of a slope, m equals rise over run. So if you have a 0 in your numerator, that means that you're just running. That's just a horizontal line. But if you have a 0 in your denominator, you've got rise, but you aren't running anywhere. So therefore, you would have a 0 in the denominator, and that would be undefined. All right, deciding whether a function is increasing, decreasing, or constant. Some recent studies suggest that a teenager sends an average of 60 texts per day. For each of the following scenarios, find the linear function that describes the relationship between the input value and the output value. Then determine whether the graph is a function of increasing, decreasing, or constant. So we're going to start with the first one. The total number of texts a teen sends is considered a function of time in days. So it's a function of time in days. So we'll just say it's in days. All right. The input is the number of days, which we've got, and the output is the number of texts sent. So we could actually make this a T for texts. That would probably make more sense to you. Text per day. So for each day, we can figure that out. And we just need to know how many texts there are per day. Well, there's 60 texts per day. So 60D. Done. This is an increasing function because it is positive. The next one is a teen has a limit of 500 texts per month in his or her data plan. Okay, I want to stop right there for a second. So for this one, anytime you're dealing with a word problem, I have found that if you change the way you think of your slope-intercept formula, because I mean, we all learned to love y equals mx plus b, right? But when it comes to word problems, it makes more sense to look at it as y equals b plus mx. And in this scenario is a perfect example. So we're going to have the function is equal to the initial value first, because they have a limit of 500 texts per month. So that's your initial value. All right. But then what's happening after that? In his or her data plan, the input is the number of days, the output is the total number of texts remaining for the month. So from that 500 text, they're going to be subtracting 60 per day because that's how much they're averaging. So in this case, it's easier to have your y-intercept or your initial value first, because then you're subtracting it. If I were to tell you T of D is equal to negative 60D plus 500, that means we're going to be subtracting 60 texts per day and adding 500. That just, to me, it doesn't go as smooth as saying, hey, we start off with 500 and we're subtracting 60 per day. That means that makes more sense to me as far as reading it. Remember, math is just a language. All right. So write it the way you understand it. All right. So this is a what kind of function? Well, the coefficient of D is negative. So this is a decreasing function, which would make sense because from the 500, the number is decreasing from there. All right, and then the last piece of this is a teen has an unlimited number of texts in his or her data plan for a cost of $50 per month. So it doesn't matter how many texts they send, how many days there are in the month, they just have to pay a straight up $50. So for this one, it's just 50. Okay, there's no D. There's no initial value. It's just the initial value. Okay. So this is a constant function. All right. Next victim. Interpreting slope as a rate of change. This is not new to you. We've already covered this. So let's just get at it. So this is just going to be the rate of change, the slope, given 2 points, x of 1, y sub 1, x sub 2, y sub 2. All right. So let's start this. If f of x is a linear function, and you've got these 2 points on the line, find the slope. All right, and then we're going to have to find out if it's increasing or decreasing. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm just going to label them because, you know, I forget these things. So don't be shy in labeling. I know some of y'all just hate to write, but I promise you it will help. So y sub 2 is 1 minus negative 2 over 8 minus 3. 1 plus 2 is 3. 8 minus 3 is 5. So there's our slope. Now we need to find what? Oh, that's all they wanted. Find the slope. Done. Is it increasing or decreasing? Well, it's positive. So it's increasing function. All right. That's all we needed to find was the slope on that one. Next victim. Population of a city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year if we assume that the change was constant from 2008 to 2012. So they're giving us 2 points here. And remember, time is always in your independent variable, in your X variable. So 2008 had 23,400 people. And then 2012 has 27,800 people. Cool. We can keep going from there. So they want us to find the change in the population per year. That's it. So M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, labeling my points. All right, y sub 2 is 27,800 minus y sub 1, which is 23,400 over 2012. One moment, 2008. I'm going to pause for just a moment. And let me find my pause. Hold on one second.